Hey y'all, let's take a look at something called direct variation. This is something that you're already familiar with. You just might not have referred to it this way. You've done proportions already in your life. Like, you know, if there were, oh, I don't know, if there were 15 kids at the party, mom made 40 cupcakes. So, oh, there are going to be 25 kids at the party. How many cupcakes should she make now? Well, you just do a proportion, right? 15 over 40 is the same thing as 25 over how many cupcakes you do, and you figure it out, cross multiply, there you go. This is the same thing, it's just worded and it looks a tiny bit different, and we solve it a little bit differently. But once you get the process down, you got it, okay? So let's do this. How to write this algebraically. There are twice as many boys as girls. You would just say, okay, well, boys is equal to 2 times the girls, right? How about there are 3 times as many boys as girls? You would go, there's 3 times as many. Okay, so 3 times as many boys as girls. Okay, there you go. All right, you know how to do that. All right, this you need to write down because this is the way we are going to write direct variation. This equation means boys vary directly as the number of girls. Okay, or the number of boys is directly proportional to the number of girls. And what you're going to do is, if it's direct variation, if it varies directly with it, you're going to make up that equation, and there's going to be a k next to the g. Whatever you're using is going to be multiplied by a constant called k, which we'll figure out what that is. Okay, so you tell me how to do this. Using that, how do we write the weight of a substance varies directly as the volume of the substance? Okay. This is the general equation if you want to write it this way. If A varies directly with B, you'll write it like this. A varies directly with B. Then we'll just plop in numbers and we'll figure out what K is, and then we'll be able to solve it. I mean, it's the same thing as doing a proportion with those cupcakes thing I talked to you about a minute ago. Okay, so the weight of a substance varies directly as the volume of the substance. So we go, okay, well, the weight varies directly as the volume. Boom, there we go. That's all you need to do. Then the problem would give you enough information to figure out W and V, and then you would figure out, oh, K is equal to 12 or whatever. Then you would do the same thing and put it in the next equation. I'll show you exactly how to do that in just a minute. All right. Force varies directly as the current. Well, that'd be the same thing, right? Force varies directly as the current. There you go. Okay. How about the distance traveled varies directly as the time? Well, here we go. The distance varies directly as the time. There we go. Same thing over and over. Okay. How about this? Now, I do want to make a point. He's going to throw stuff at you. You know how he throws in those long vocabulary words and these weird names? You know, so-and-so drove 86 miles. And you go, who was that? Who would name their kid that? Okay. You throw a Grace in the end of it. It's a homeschool girl's name. But this, you don't have to worry about even what all this stuff means. You just still write it using the method. So the circumference of a circle is directly proportional to the length of the radius. That's a bunch of hooey. We can call it circumference is directly proportional to the length. Let's just say length. Or you could say R for radius. Doesn't matter. Whatever is easier for you. All right, here's another one. The volume of a right circular cylinder of fixed radius is directly proportional to its height. That's a lot of hooey, but it's basically the volume is directly proportional to the height. So just go volume directly proportional to height. And there you go. So train yourself how to do that, and these things will go really easily. All right, let's put this into practice here. All right, we have an example. The mass of a substance. Oh, look at this. We got the word substance. We got the word volume. We got liters and kilograms and all this jazz. Don't worry about all that stuff. We're just doing a proportion problem. That's all we're doing. And we're going to use this. Varies directly. Something varies directly with something else. That's our basic one. And let's take a look at what does vary. Mass varies directly as the volume. So how would you write that as an equation? You'd go mass varies directly as the volume. That's what we're going to use, okay? That's our basic equation we'll use, okay? Well, let's find out what that K is. But what usually happens is we find the K and then apply it to the next equation. If the mass of 2 liters of the substance is 10 kilograms, okay, so the mass is 10 kilograms, Now it's 2 liters of the stuff, so it's going to be K times 2. That's the volume. Liters are volume, right? So we found out that K is equal to 5, all right? Now what we're going to do is use both of these equations right here to solve the actual last part of this, okay? All right, they ask what will be the volume of 35 kilograms of the substance. Well, okay, well the mass in this is our equation, right? We have mass equals is directly varies directly as the volume, and we have the K, the constant, is 5, okay? So this is our basic equation. Let's just go ahead and write it. M equals K times V again. Except for this time we found out what the K equals. It's 5, right? They ask what will be the volume, so we don't know the volume. But we know it's going to be 35 kilograms. So there we go. That's all you need to do. So volume is just 35 divided by 5, or 7. And that's it, okay? In other words, you go, it varies directly, that's your equation. You make it into what the word problem says. You figure out what K is, then you stick the K into the next example of the proportion that they give you. Let's try another one. All right. Oh, look at there. I actually forgot I had steps for you guys. Here we go. Step 1, write the basic equation, which is A equals K times B. Find K, and there we go. So, and that's what we just did. All right. So let's do another one here. The distance traversed. I've never traversed in a car in my life. I don't think that's legal in my state. Okay, anyway, I don't want to catch any of you guys traversing in a car. Okay, anyway. All right, the distance traversed by a car traveling at a constant speed is directly proportional to the time spent. Oh, that's a lot of hooey. Look at all that long sentence. Gee whiz. Okay, basic equation is something varies directly as something else, right? Okay, so the distance varies to the time, right? That's the long and short of this. The distance is directly proportional, which means varies directly to the time, okay? Well, let's just do that. What do you write? Distance is directly proportional to the time. There we go. Varies directly with the time. Good enough, okay? If the car goes 75 kilometers, what is this? Europe? We go miles here in America. All right. 75 kilometers in 5 hours. Stop. Okay? The distance is 75. We don't know what the K is. That's what we're trying to find. But it goes in 5 hours. So there we found it. So K is equal to 75 divided by 5, or 15. Okay? So we're going to use our basic equation here, and we're going to use the K to figure out the answer to the problem. The problem is, how far will it go in 7 hours? Okay? Well, let's figure it out. We've got D equals K times T, all right? Well, we figured out what the K is, right? The K is 15, okay? How far will it go, the distance? We don't know. In 7 hours, that's the time. Boom, there we go. So D is going to be 15 times 7, or 105. And there we go. And again, let's look at this problem. You could just go, oh, the car goes 75 kilometers in 5 hours. In other words, you go 75 to 5 is how far? I don't know. To 7 hours. You can just cross multiply and find it's the same thing. Just a new method. All right? Learn the method. Okay? Let's try another one. This is under certain conditions of the pressure of a gas varies directly as the temperature. Okay, stop right there. Let's just break it down. The pressure of a gas varies directly as the temperature. So let's make it easy. The pressure varies directly as the temperature. We got it. That's our equation. When the pressure is 800, okay, we got 800. The temperature is 400. All right. Ooh, they kind of tricked us there. There's a K there. Look at that. Okay, it looks like that K, but don't worry about it. Forget that. The temperature is 400. So K times 400, that's what we're going to use to find out K. Well, K is obviously 2 then, right? We figured it out. Okay. So now they're asking us, what's the temperature when the pressure is 400? Okay, well again, let's just use the same equation. P equals the constant times the temperature, pressure and temperature. What is the temperature? Which means we don't know this. With K, we do know, right? We figured out it was T. And the pressure is 400, and there you go. So 2 times what gives you 400? 200, and that's it. And there you go. Okay, all right. All right, here's the other part of this. This is the last part we're going to do, is inverse variation. Inverse. In other words, it doesn't vary directly, it varies inversely. You kind of flip it. So look at this. Sales of a toy vary inversely with the cost. Now think about this. You could do something like, the more hours you work, the more money you're going to make, right? That's a direct correlation. Directly, it varies directly, right? If you work 8 hours and you make $10 an hour, you'll make $80. If you work 12 hours, you'll make 120. So it varies directly with that. But look at this. You sell a toy, it varies inversely with the cost. In other words, what happens to, the price is going up for the toy. What happens to the number of sales when the price goes up? It goes down, okay? When the price of the toy goes down, then more people can afford it and it goes up. So we're going in different directions. That's inverse variation. Okay, all right, here's another one. Excuse me, I forgot to write this. So sales of the toy vary inversely. Well, here's the basic equation. If this was direct variation, you multiplied them, you multiplied K and B, direct variation. What do you suppose you're going to do between K and B if it's inverse? You'll divide, right? It'll be K over B. That is your basic equation with inverse variation. So make sure you know that. Okay, inverse is this one. Sales vary inversely with cost. That means you'd go, okay, the sales vary inversely with the cost, like that. You might even put toy. Toy varies inversely with the cost. Revolutions per minute varies inversely with the diameter. Well, you could say, okay, that's going to be revolutions vary inversely with the diameter. There you go. You just put it over. Anytime it's inverse, you just divide. The pressure of a perfect gas varies inversely as the volume. Well, okay, fine. The pressure varies inversely with the volume. There you go. You're going to do exactly the same technique we did on the last kind of problems. You ignore all the complicated sounding, units and all that kind of stuff. And, it's chemistry. I haven't done this. Doesn't matter. You just learn how to write those two equations. Direct variation is A times KB. Indirect is, A equals K over B. Okay, let's do another one. The current varies inversely as the resistance. Okay, so the current varies inversely as the resistance. Boom, there you go. Okay, how about the velocity is inversely proportional to the time. So velocity inversely proportional to the time. And the same thing, we're going to figure out what K is, apply K to the new equation and solve it and be done. All right, let's try one. Under certain conditions, the pressure of a perfect gas varies inversely as the volume. Okay. All right, well, let's do it. The pressure varies inversely as the volume. So we're just going to go, okay, pressure varies inversely as the volume. We're going to use that equation, just like we did a couple of slides ago. Excuse me, when the pressure is 7, don't worry about pascals and all that stuff. Okay, when the pressure is 7, so let's go ahead and put the numbers in. Pressure is 7. The volume is 75. Okay, now we're going to need to find out what K is. So how do we do this? We're going to use cross multiplication. So 1 times K is 7 times 75. And you're going to have to, go ahead and do the arithmetic. And I'll just tell you right now, it's 525. So we have found out that K is 525. We're going to use this equation or use the value for K to find their question. What would be the volume if the pressure is increased to 15 pascals? Okay, so use the same thing over here. We got pressure is inversely proportional to the volume. Okay, well, they're asking what would be the volume? So that means we're not going to know this. The pressure is increased to 15, so let's just stick it in there. We got 15. All right. And we know what the K value is, right? It's 525. Okay, so we just need to find out what V is. And we do the same thing, just cross multiply. So we have 15 times V equals 525. 5. And if you do the arithmetic, you will find out that the volume is 35. And there we go. Okay. All right. And let's try another one. To travel a fixed distance, the rate is inversely proportional to the time required. It's a lot of hooey again. You tell me. Look at that first sentence. Pause it if you need to. Give me the equation for the first sentence. Rate inversely proportional to the time. Bam. There we go. When the rate is 60, let's figure it out. We got 60 over here for the rate. The time is 4, so we don't know the k. We know the time is 4. So let's cross multiply again. 1 times k is k. 60 times 4 is 240. We have just figured out what k is. We'll use both those equations to figure it out. All right? What would be the time if the distance, blah, blah. Okay, so here's our basic equation. R is equal to k over t. We know what k is. We can stick it on in there. Yoink, right there. And that's 240. What would be the time, which we don't know, if the rate were increased to 80? All right, let's increase the rate to 80. Okay, there we go. And we can do the same thing, over 1. So 80 times t is equal to 1 times 240. And t is going to be equal to 3. And there we go. Same thing. Okay. All right. Looks good. Let's try a couple of practice problems. There's 3 of them, so let's do all 3. A, pause it and try A. All right, the mass varies directly as the volume. This is your equation. Directly as volume. Don't forget, that's multiplication. All right? The mass of 30 kilograms has a volume of 6 liters. That means times 6. So K is equal to 5. Okay? So we figured out this, we figured out that. So let's use it. M equals K times V. Okay? All right? Is the volume of 65 kilograms of the substance? All right? So we need to know the V, which we don't know. The K, we do know. That's 5, right? And the mass would be 65. So 5 times what gives you 65? If you do the arithmetic, you're going to find out. It's going to be 13. And there you go. All right. Pause it and try B. Okay. Pressure varies directly as the temperature. Okay, so we'll say pressure varies directly as temperature. If you put gas varies directly as temperature, I mean, that's probably okay, I guess. But try to keep it in your head. You're already talking about pressure here. Okay, when the pressure is 1200, so that's 1200, the temperature is 300. So there we go. And of course, don't get fooled by saying, oh, 300 K, that's a temperature notation. That doesn't mean the same thing as RK. So K is going to be 4. 4 times 300 is 1200. So they're asking, what's the temperature when the pressure is 300? Well, this is our basic equation still. P equals K times T. K we figured out was 4. They're asking what the temperature is, and the pressure is 300. Well, 4 times what gives you 300? That's the key. If you did the arithmetic, that'd be 75. So there we go. Okay. All right. Try C. Pause it there. All right. We got pressure varies inversely as the volume. What's that equation look like? We got inverse. So pressure varies inversely. That's our equation. All right. When the pressure of gas is 9, so I have a 9 there, the volume volume is 100 liters. So we figure out our K, we get 100 for volume, and of course 1 times K is going to be 9 times 100. So we figured out our K is equal to 900. Good, we're going to use both of those, okay? What would be the volume if the pressure is increased to 20? Okay, well we can do that. And we've got our P is equal to K over V, all right? Well, they say the pressure is increased to 20. Well, fine, we'll put it in 20. 20 is equal to K, we know is 900. And so we need to find out what is the V, okay? Well, 900 divided by what gives you 20, basically. Or of course, we can do the cross multiplication if you want. So 20 times V is equal to 900. And if you did this long division, or however you want to handle it, the V would be 45. And there we go. Okay. That's direct variation and indirect variation. All right. See you guys next time. Y'all have a great day.